Here's how to do a couple of the trickier problems on our inverse trig function worksheets. So let's start out with this first problem. Sine of inverse cosine of 3/5. Well, when I do inverse cosine, that tells me that this value right here, this 3/5, that's a trig value. And since it's cosine, it represents adjacent over hypotenuse. So I'm going to draw a quadrant 1 triangle, since it's positive, with an adjacent side of 3 and a hypotenuse of 5. Using the Pythagorean theorem, or just remembering that this is a special Pythagorean triple type triangle, you can figure out then that the opposite side is 4. I want to find sine of the angle that has 3/5 as its cosine value. So I'm just wanting to find sine of this angle. Sine of theta is opposite over adjacent, or 4/5. So that is the answer. Now let's do the same type of problem, only now what's inside here is an x. First of all, you got this kind of weird word here, arctan. What does arctan mean? It means the same thing as inverse tangent. So when you see arctan, you can just replace it with inverse tangent. So that tells me that this x is a trig value. Now, sine or tangent is adjacent or opposite over adjacent. So I only have x here, so I'm going to write it as x over 1. So I have a side that can be the opposite side and a side that can be the adjacent side. Now, since this is an unknown number, I don't know whether it's positive or negative. If it was positive, I'd draw a quadrant 1 angle. Since this is tangent, if this was negative, I'd have to draw a quadrant 4 angle for inverse tangent. So I'm going to just draw both. So I have a case where x is positive and where x is negative. So for x greater than 0, this would be the opposite side and the adjacent side would be 1. In quadrant 4, for x less than 0, this would be the opposite side, and this is the adjacent side of 1. Now what I want to find is, for either one of these angles here, I want to find what the cosecant value is. So what is cosecant of theta? Well, for cosecant, which is the reciprocal of sine, I need to know hypotenuse over opposite. I know the opposite side is called x, but I don't know the hypotenuse. Just like if we had dealing with numbers, I need to use the Pythagorean theorem. So I would have to say 1 squared plus x squared is equal to the hypotenuse squared, or 1 plus x squared equals the hypotenuse squared. I have to take the square root to find the hypotenuse. So the hypotenuse is the square root of 1 plus x squared. Don't make the mistake of saying, oh, that can be simplified to 1 plus x, because it cannot. And if you want to know why, you can talk to me about that. Now, cosecant of theta is hypotenuse over opposite, so cosecant of theta is equal to the square root of 1 plus x squared over x. Now, why would I want to rewrite this expression that has inverse, tangent, and cosecant as an algebraic function of x? Well, it turns out in calculus it's a lot easier to do certain calculus procedures, the integral and the derivative, on an algebraic function than it is on some of the trig functions. So this will simplify things for those of you who are going on to calculus. Now the last step of this problem is state the domain on which the equivalence exists. If you look at the instructions on some of the worksheets that have this, what domain is this valid for? Well, if you look back at the original expression, inverse tangent has a domain of all real numbers. If you go back to your notes, you'll see that, because the graph looks something like this. It shows that it's kind of a sideways curve with asymptotes above and below. So I can go all in any amount, any type of angle, or I'm sorry, any trig value is valid to put in there. However, when I look at the equivalent in algebraic form, I do notice a value of x that I can't use. X can't equal 0 because it would make the denominator equal to 0. So the domain of this is all real numbers except x cannot equal 0. So there's a couple of tricky problems for you. The last thing I want to talk about is some of the problems that involve explanation. One of the problems that you had on your worksheet was inverse tangent of 2 inverse sine of 2 and inverse cosine of 2, and you're supposed to get those values. Now, if you tried inverse tangent of 2 in your calculator, you might have gotten this crazy looking expression. To get the decimal answer, put an inverse tangent of 2 and push Control Enter instead of just Enter, and it will give you the decimal equivalent. Apparently your calculator thinks this is helpful, not terribly helpful to me. Now when you do inverse sine of 2 and inverse cosine of 2, you get an error message, non-real result. So why is it that you get a number for inverse tangent and an error message for inverse sine and inverse cosine? Well, the reason is that inverse tangent has a domain of all real numbers. And the reason it has a domain of all real numbers is because this is a trig value. And this trig value represents opposite over adjacent. Can the opposite side be bigger than the hypotenuse, or bigger than the adjacent side? Certainly. The opposite side can be bigger than the adjacent side. So it's okay to have a number, the number 2. That's perfectly reasonable. As a matter of fact, the opposite side could be 10 times bigger than the adjacent side, and this would be 10. However, when you look at sine and cosine, the domain for sine and cosine both is -1 to 1. Remember, the graph looks like this. This is the inverse sine one. It's the curved graph, and it only goes from -1 to 1 on the x-axis when we're talking about the inverse function. That's because sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. The opposite side and the adjacent side can never be bigger than the hypotenuse in a right triangle. So if I asked you to explain, you need to explain using the domain and the definition, the SOHCAHTOA definitions of sine and cosine. You explain in sentences why inverse tangent of 2 gives you 1.10715, and those two give you non-real answers. So that's another type of problem that I'll ask you about inverse functions.